Dear students, in the last class I derived two important equations. One equation for drift velocity, which is Vd, magnitude of the drift velocity, is equal to E tau by m, where E is the electric field, small e is the charge of an electron, tau is the relaxation time, and m is the mass of the electron. And also we have derived an expression for current in a conductor, which is N A E V D. N stands for number of free electrons per unit volume, which is also called as the free electron density. A is the area of cross section, E is the charge of the electron, and V D is the drift velocity. You can even write this drift velocity to be equal to V D is equal to L by T, where L is the length of the conductor and T is the time taken by the electron to cross the conductor, whose length is L. Now, based on these equations, so let us try a numerical from the examination, which is March 2017. So, the statement goes like this: calculate the current density, which is J. We need to calculate the current density. This is to be calculated current density and the average drift speed of the conduction electron. So, I have to find even the value of the Vd, drift velocity of the conduction electron in a copper wire of cross sectional area. A is 10 to the power minus 7 meter square, carrying a current of 1.5 ampere, and further given that the free electron density, which is N, is 8 into 10 to the power 28 electrons per meter cube. So, meter to the power minus 3. Further, the value V is given 1.6 into 10 to the power minus 19 coulomb. Now, current density is nothing but J. So, J is equal to current flowing per unit area of cross section, I by A. So, to find J, I need the value of I, and to find I will use N, A, E, V, D, where V D is the drift velocity, and current N, A, E, V D, and then to find V D we need current, which is 1 point of here, N is given here, A is given, E is given, everything is given. So, we need V D here, so which is I by N, A, E. So, the value of I is 1.5 by the number of free electrons per unit volume. It is 8 into 10 to the power 28, and the area of cross section, which is 10 to the power minus 7, and then divided by the value V, which is 1.6 into 10 to the power minus 19. So, let us find this value of Vd, which is 1.5 divided by 8 to the power 28, and then further divided by 10 to the power minus 7, and then further divided by 1.6 in 10 to the power minus 19. So, when you simplify this, you will get 3.516 into 10 to the power minus 3. It is a velocity, so it is in meter per second. So, that is the drift velocity. So, direct substitution problem. After that, current density, which is I by A, the value of I is 1.5 divided by the value of area of cross section, which is 10 to the power minus 7. So, that will be 1.5 in 10 to the power plus 7. It is a current per area. So, it is ampere per meter square is the unit of current density. So, 5 marks question, an easy one. So, if you know the formulas and then you know how to simplify this, you can very easily get 5 marks in the examination. So, it is most important that you must know all the formulas are relevant to it. So, here it is a direct substitution problem. So, let us try one more numerical based on the same topic. The number density of free electrons, that is number of free electrons per unit volume, N is given, which is 8 into 10 to the power 28 per meter cube. How long does an electron take to drift from one end of a wire of length L is given, which is 2 how long, that means we need to find the time, how long to its other end. The area of cross section of the wire A is given, which is 5 into 10 to the power minus 7 meters square, and it's carrying a current of 2 ampere. So current of 2 ampere. So here we need to find the value of t based on the value of L. So we know the formula for drift velocity, Vd is equal to I by NAE. We also know the formula for drift velocity is equal to the distance by the time. Distance means here the length of the conductor. So based on this equation, I am going to equate I by NAE is equal to L by T. So based on this, we need to find the value of t. So rearrange for t. So t is equal to L NAE divided by I. So let's do the substitution here. So the value of t is equal to, so the first length, which is 2 meter, into free electron density, which is 8 into 10 to the power 28, into the area of cross section 5 into 10 to the power minus 7 divided by the value of the current, which is I, that's 2. Okay, so this 2 will get cancelled here, and then we have 8 5s are 40 into 10 to the power 28, and minus 7 is 21, and then if I rearrange, I'll get 4 into 10 to the power, this is 22. So time taken t is equal to, it's 4 into 10 to the power 22 second. Okay, so we have Vd is equal to I by NA, current per, then Vd is equal to length by time, and when you equate I by NA is equal to L by T, and you have to rearrange, T is equal to L into NAE by the value of I. Okay, so the value of L is given, which is length 2 meter, which you have substituted here, and then the value of N is 8 into 10 to the power 28. Area of cross section is given, which is and then we didn't substitute one of the value here, which is E, right. So the value of E is 1.6 into 10 to the power minus 19. Then we'll substitute here 1.6 into 10 to the power minus 19. Then it's here again into 1.6 into 10 to the power minus 19. And then when you multiply here 1.6, 16, 4 is 64, 6.4 into 10 to the power 22 and minus 19, which is plus 3, correct. So plus 3 second. So that was the substitution which we missed here, so which is E. Okay, all right. So hope you have understood now the value of the time taken to cross the conductor is given by this. Again, it's a direct substitution problem. Only thing, you have to equate two equations together here. Okay, right. So next, so we have an important law again. The statement has appeared twice in the examination, and it's about a law called Ohm's law. Now, what exactly this Ohm's law about? For that, to understand, we are going to consider a conductor connected to a battery. Let V be the potential difference across the conductor, and due to which the current will always flow from positive to the negative. This is called conventional current, always from higher potential to the lower potential. Electrons will move from lower to higher, whereas the current, which is conventionally represented as higher to lower, like this. Okay, higher to lower through the conductor. Now here we find that as we increase the voltage, current also increases. So I is directly proportional to V. More potential difference, more current. Less potential difference, less current, and no potential difference means there is no current. So, current through a conductor is directly proportional to the potential difference between the ends of the conductor provided its temperature, this temperature of the conductor, and other physical conditions. Now, physical conditions means the dimensions of the conductor, like the length of the conductor, area of cross section of the conductor. So, all this factor we should keep constant. So, only then this statement is valid. So, what is the exact statement? The current through a conductor is directly proportional to the potential difference between its ends when its temperature and other physical conditions remains constant. So, this is called Ohm's law. So, what is the statement of the Ohm's law? The current through a conductor is directly proportional to the potential difference between its ends when the temperature and other physical conditions remains constant. So, I is proportional to V. We can even write V proportional to I. And now the proportionality constant is replaced as a R. So, that is how we get V is equal to IR. You can even remember this equation like this, very important relation. Very important relation where V stands for not exactly very here, it is potential difference. I is the current and R is the constant called electrical resistance of a conductor. So, what is the mathematical form of the Ohm's law? The mathematical forms of the Ohm's law is that V is equal to I into R, where R is equal to V by I. V is measured in terms of volt. Current is measured in terms of the ampere, and so unit of the resistance is volt per ampere, but we have an alternative unit named after ohm. So, that is why the unit of the resistance is ohm and omega is the symbol used for it. So, 1 ohm is equal to 1 volt by 1 ampere. Current through a conductor is said to be 1 ohm, not the current. The resistance of a conductor is said to be 1 ohm when a potential difference of 1 volt applied across the ends of the conductor produces a current of 1 ampere. So, do remember the mathematical form of the Ohm's law, which is V is equal to IR, potential difference, current, and R is the resistance of the conductor. Reciprocal of the resistance. Reciprocal of the resistance is denoted by G, and this is called electrical conductance, and it has a unit which is Siemens. Okay, SIEMENS. Siemens is the unit of the conductance. Okay, MENS. Okay, it's a Siemens is the unit of electrical conductance. So, reciprocal of resistance is called conductance. Now, what are the limitations of the Ohm's law? So, question has appeared 5 times in the examination. What are the limitation or the condition under which the Ohm's law is valid? So, limitation number 1, Ohm's law is applicable only for conductors at constant temperature and if all physical conditions of the conductor remains the same. So, that is what the condition based on which we state the Ohm's law. So, when Ohm's law is valid, so Ohm's law is applicable only for conductors at constant temperature and if all physical conditions of the conductor remains the same. The limitation number 2, it is not applicable for the diode, transistor, thermistor, triode, pentode, discharge tubes and electrolytes. So, these devices are called non-ohmic devices, the devices in which the Ohm's law is not applicable. Now, how to verify whether the Ohm's law is applicable or not applicable? See, based on this equation, V is equal to IR. This is of the format Y is equal to MX. That means the graph of V versus I is a straight line, linear. So, any device which obeys Ohm's law are called ohmic devices. Example, the measuring devices like voltmeter, and then we have ammeter and galvanometer. So, these are all ohmic devices. For all ohmic devices, V versus I is a straight line, linear graph. For non-ohmic devices, V versus I is not a straight line, it is non-linear. Such devices are called non-ohmic devices, and these are all non-ohmic devices. A diode, which is one of the semiconductor device. Transistor is also a semiconductor device. Thermistor, again a non-ohmic device. Triode, pentode. So, these are all work on the phenomenon of thermionic emission. So, for all these devices which we have listed, whether it is a discharge tube or electrolytes, the Ohm's law is not applicable. So, this is the second, the limitations of the Ohm's law. And the third one, the current voltage relationship varies with the change of polarity of applied potential difference. So, I am going to explain that, what it means. Suppose if I take a device like a diode, and if I connect the diode like this. So, then again I am going to connect the same diode in a different manner like this. See this here, the positive of the diode is connected to the positive terminal of the battery. Here the negative is connected to the negative terminal of the battery. But here the positive of the diode is connected to the negative terminal, and the negative is connected to the positive terminal. Therefore, these two combinations are not same, they are different. See, current voltage relationship, that means the current that we get here in this circuit and the current that we get here in this circuit are not the same. Okay. So, current voltage relationship, it varies with the change of polarity. See, there is a change of polarity, plus plus, this is plus and the minus. Okay. So, that is what the limitation, we do not get the same current in two circuits. So, which means the Ohm's law is definitely not valid. So, these are the three important limitations of the Ohm's law. The first one, Ohm's law is applicable only for conductors at constant temperature, and if all physical conditions of the conductor remain same, and it is not applicable for diode, transistor, thermistor, triode, pentode, discharge tube and electrolytes. And finally, the current voltage relationship varies with the change of polarity of the applied potential difference. Okay. So, important again question. So, do remember these three limitations. Now, what is ohmic devices? So, I have already explained it. So, devices which obey Ohm's law are called as ohmic devices, and example for them are the galvanometer, voltmeter and ammeter. After that, we have what is non-ohmic devices, give an example. So, devices which do not obey Ohm's law are called as non-ohmic devices, and transistor, diode are example for non-ohmic devices. So, both the questions have appeared again once in the examination. So, let us see more about it. So, define electric power and mention the expression for electric power. So, whenever we use a device like let us consider a bulb. Okay. So, if there is a filament bulb connected to a battery. So, current flows through the circuit, which is I, and V is the potential difference and R is the resistance of the bulb, and this bulb starts glowing. Now, when the bulb starts glowing, electric energy is converted into heat energy. Electric energy is converted into heat energy. So, what is the amount of the heat energy which is developed? That is given by H is equal to V I into T. What is V I into T? V is the potential difference, I is the current, and T is the time. Time during which the heat flows. But we also know that V is equal to IR. That is why we get here V is IR, I into I square R into T. So, this is another formula. We can even replace I as a V by R. I from this is equal to V by R. So, if I replace I as V by R, I will get V square by R into T. So, these are three different forms of the amount of heat generated in a conductor. So, this is called heating effect of electric current. So, when we pass current through a conductor, it generates heat, and this principle is used mainly in electric heater. We also use in filament bulb, and the most important in an iron box. In iron box, we use this principle of heating effect of electric current. And what is the amount of heat generated? This is what we measure. Now, heat generated per time or amount of electric energy consumed per second is called as the power. So, that is why H by T will give you V into I, will give you I square R, will give you U square by R. So, rate at which the electric energy is consumed is called as electric power. So, electric power is defined as the rate at which the electric energy is consumed, and this is the three different formula for electric power. P is equal to V I square R, V square by R. In every electric devices, they print what we call the rating of the device, something like this: 50 watt, 220 volt. So, 50 watt is the maximum power that device can consume when you apply a voltage of V. From this, I can find I. I is equal to, from here, based on this, here it is, I is equal to P by V. I is equal to P by V. You can even find the value of R. Use R is equal to V by I. So, once you know that this is called the rating of the device. So, different devices have different rating. For LED bulbs, we have 5 watt bulb, 14 watt, 11 watt, different watts bulbs are available. For a television or a computer, we need about a power of 90 watt. If it is iron box, we need a power of about 700 watts. If it is electric heater, we need more than 1000 watts. So, different devices consume different amount of the power. So, our electricity bill is based on total power that we consume for a month. So, and that is decided by the rating of every devices. LED bulb, very small LED bulb, one single bulb that normally which is used as an indicator, in the television. When you switch on the television, there is an indicator, a red indicator. So, that will consume a very less power of about 0.5 watt. So, a single small LED bulb will consume lesser power. That is why LED devices are highly used in most of the appliances. Okay. So, hope you have understood the formula for the power, three equation: P is equal to V I square R and V square by R, and definitely the SI unit, the power is always measured in terms of the watt. So, they mention the factors on which the resistance of a conductor depends. See, resistance of a conductor R is directly proportional to the length of the conductor. More length, more resistance, and inversely proportional to the area of cross section. That means thinner the wire, more is the resistance. So, that is why in fuse, electric fuse wire, normally we use a very thin wire. The reason being, lesser the thickness, more is the resistance, and when the resistance is more, and when high current flows through it, that fuse is get burnt very easily, quickly, so that it acts as a safeguard for the rest of the home appliances. Okay. So, R is proportional length, directly proportional length, inversely proportional the area of cross section with a constant which is denoted by rho L by A, and this rho is called the resistivity of the material of the conductor, resistivity of the material of the conductor. So, R is directly proportional length and inversely proportional area of cross section, and rho is the resistivity of the material of the conductor, which is given by, therefore, they have asked what are the factors on which resistance of a conductor depends. It depends on mainly three factors. One, length of the conductor. other is the area of cross section, and the third one is the temperature of the conductor, because with the change in temperature the resistance also it varies with the conductor. How does resistance of a conductor vary with its length? So it is directly proportional to the length of the conductor. These are all 1 mark question from the examination. So if I rearrange for rho, I will get R A by L. Rho is equal to R A by L. Now if it is a wire has an area of cross section which is circular. So that is why the value V is a pi r square by L, or R into, if it is in terms of the diameter, pi d square by 4 into L. So A is pi r square, where R is the radius of cross section of the wire, and D is the diameter of the wire, because radius is a half of the diameter, so that is why I will get d square by 4. So this is the formula for resistivity of the material of a conductor. Now what is the definition of the resistivity? See, rho is equal to R if A is 1 and L is 1. So this is A1 means unit area of cross section of unit length. So resistivity of a material of a conductor is equal to the resistance of a conductor of unit length and unit area of cross section. So how do we define resistivity? Resistivity of material of a conductor is equal to the resistance of a conductor of unit length and unit area of cross section. So what is the equation for resistivity? It is already given here. Rho is equal to R A by L, that is R into pi r square by L, or R into pi d square by 4 L. What is the SI unit? So rho is equal to resistance R in ohm, area meter square, length in meter, this meter will get cancelled. So you will get the resistivity equal to ohm meter is the unit of resistivity, okay, unit. What is electrical conductivity? Reciprocal of resistivity is called as a conductivity. Ohm meter is the unit of resistivity. So reciprocal 1 by ohm meter, that is per ohm per meter. But per ohm is nothing but the Simon, correct. So Simon per meter is the unit of electrical conductivity. Reciprocal of resistivity is called as electrical conductivity. So if the conductor, it conducts the charges very easily, so that is why it has a greater electrical conductivity. Insulator, it does not conduct at all, correct. So that is why its conductivity is 0, and its resistivity, when this is 0, resistivity is very high for the insulators, okay. So that is how we define conductivity and resistivity. So the definition is the reciprocal of resistivity is called as conductivity, and the equation is given, sigma is equal to 1 by rho, and the SI unit is a Simon per meter is the unit of electrical conductivity. So next we have equivalent form of Ohm's law. Equivalent form of the Ohm's law. I am going to start with the V is equal to IR, which is the Ohm's law. Then I will replace R as rho L by A. I is equal to rho L by A. Then I will rearrange. V by L is equal to I by A into rho. V by L is nothing but E, electric field. I by A is nothing but J, which is current density, and then rho. And now if I rearrange, I will get J is equal to E by rho, E by rho. And 1 by rho is nothing but sigma. So this is how we get a relation. J is equal to sigma into E. Here J is a vector, it's a vector quantity. Electric field is also a vector. So we started with the V is equal to IR and we ended up with G is equal to sigma into E. So this is the scalar form of the Ohm's law, and this is the vector form of the Ohm's law. Okay, it's a equivalent form which is a scalar, and this is the vector form of the Ohm's law. So current density is equal to electrical conductivity into electrical field, which is E. So this is also again an important question, appeared once in the examination. Expression for electrical conductivity. So for that I am going to start with the expression for current. I is equal to N A E V D, and then let us replace N A V D as E E tau by M. I is equal to N A E and V D is nothing but E E tau by M. I will rearrange here I by A, and then we have N E square E tau by M. What is I by A? I by A is nothing but J N E square E tau by M. But J is nothing but sigma into E, just now we derived it, right? So N E square E tau by M. The value B will get cancelled. So finally we get sigma is equal to N E square tau by M. So this is the expression for electrical conductivity of a conductor. What are the variable? Where N is free electron density, charge of the electron, relaxation time, and M is the mass of the electron. Okay, and you can derive it based on this particular diagram. Okay, so where you can see there is a current, there is a potential difference, L is the length of the conductor, V is the drift velocity, and E is the electric field. So hope you have understood this derivation, important one, 5 marks question from the examination. Okay, right. So go through all these equations. So plenty of equations, plenty of important concepts we have discussed today. So read all this topic because there are plenty of derivations in every chapter, and this is the most important chapter of the entire syllabus because the weightage is more. I am going to continue the rest of my topics in the next class. Thank you.